Algebra 2 students. This week we are going to learn about the number e, the natural logarithm, and how to simplify expressions that contain them and solve equations with them. So let's start with probably your first question. What is e? And e is an important mathematical constant. Similar to pi, it is an important mathematical constant. E is approximately 2.718. It is an irrational number, and it's also the base of the natural logarithm. It's sometimes called Euler's constant. So there are numerous ways to calculate E. We looked at one case in class on Monday. That's illustrated here in this first example. A second way we can calculate E is by looking at the sum of the expression 1 over n factorial. So that's what those exclamation points are. They mean factorial. 3 factorial is 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1, and so on. So that is one way that Euler, who E is named after, he used that method to calculate E to 18 decimal places. Okay, so those are a couple ways of calculating E, but the applications for E come in a couple places. E describes what we call natural growth. So if you think of a cell, for example, okay, and maybe it doubles, okay, so then we have the original cell plus a new cell, okay, so it's doubled. The thing is that doubling doesn't just happen out of nowhere. Okay, so what happens is actually this original cell grows slowly and slowly and slowly over time until boop, it pops into a second one. So that's why E is a way of describing natural growth. Because when we are actually doubling things, which is a very natural thing to happen, it doesn't just magically come out of nowhere. It's slowly growing over time. And so then by the time we're done, we actually have more than 2. We have that 2.7. So it is also used in compound interest, which is applied in finance a lot. We have done numerous interest problems in this class so far when we've looked at exponential growth. But most of those formulas aren't actually used in the current finance world because they're just very simplified. What we typically see in finance is interest that compounds. That's what happens on credit cards, mortgages, things like that. So E is applied to those formulas that are actually the ones that are more frequently used. All right, I think I've got, no, here we go. So let's start by looking at what does the graph of E look like. We'll look at the parent function in a moment of e to the x, but right now let's just practicing inputting values for x in expressions or equations that involve e and then plotting them on a graph. So I'm going to start by making a table. I'm going to start my table, I think, at -1, and then if I need to add more negative values, I'll add more from there. I'll go backwards. So I'm going to start with -1, 0, 1, 2, 3. Let's start with this and see where we get. So here's our expression, e to the x minus 2. So the E button, typically on your calculator, is found above the ln button. So I have a button on my calculator that says log, and then right below there I have one that says ln. My e to the x button is right above the ln. Oh, you can't see that. I was writing right underneath where my face is. So right underneath the log button is where I see ln, and then I have my e to the x. So I am going to put in, okay, so I'm going to press second ln to get my e to the, And now I'm going to do -1 minus 2, close the parentheses, plus 1, enter. And I get 1.0497. I'm going to round that to probably 1.05. Now we'll put in the 0. So second ln, 0 minus 2, close those parentheses, and then add 1, and I get 1.135. Again, I'm going to round to the hundredth, so that would be 1.14. Okay, so keep going. If you need to pause the video to keep inputting those numbers, make sure you're actually doing this and checking that you're getting the same thing as me. Because if you're not, then that's a great thing to ask about in class or in office hours. Okay, how to make this work on your calculator. So my next value I get is 2. Then I have 3. Oops, I'm sorry, I read that wrong. So when I put in a 1, I get 1.37. Then I get a 2, and then 3.72. I'm just going to go one more. When I put in 4, I get 8.39. Now let's go ahead and plot these on our graph. I think I'll be okay with just having that -1 there. So I'm going to draw my axes. My x value, I don't need to go very negative. My y, I have no negatives, so I'm going to just draw it kind of in the corner here. So this will be my 0, 0. So -1, a little bit more, up 1, over 0, up 1, over 1, up 1 and something, over 2, up 2, over 3, up 3.7, wait, 3.7 about right there, and then over 4, up 8.5 almost. I think we're about right there. So it looks a little bit like this. Okay. So what kind of function does this look like to you? It's an exponential function. Okay, it has an asymptote. In this case, it looks like the asymptote is approaching 1. I know that 1 is the asymptote because I see this +1 at the end of my function, so I know it's been shifted up 1. I know it's exponential growth because e is approximately 2.71, and so I know if the base of my exponential function is greater than 1, it's exponential growth. So those are a couple things that connect back to what we already know. Okay, I'm going to pause the video right now, and when we come back, we'll look at the natural log and how to use e and natural log in a couple different types of equations.